Hello, I'm Roman, and welcome back to the series of the videos of neural networks from scratch in Golang, where we dive into the bare bones of neural networks. And again, we're using the book called Neural Networks from Scratch in Python, but as you can understand, we're not using Python, we're using Golang, just to make things more complicated and more challenging as they already. And I want to remind that I have a main channel on the YouTube. You will find the link in the description. I talk about various things around tech industry, but I needed to split these YouTube channels just not to confuse YouTube with different lengths of the videos. Now let's go. In the previous video, we managed to create a chain of the layers. So right now we have an input, we have two layers, and we have a chain of processing. We take the input, we take the input, we get the output, and we take the output and you pass it to the second layer, and we get the output. And right now we're going into we need to understand how we can define the output layers, and the book takes a little bit a different direction. And right now we're trying to implement the spiral data function, one that will return this set of the dots. So for example, we don't have to manually create inputs and weights, like random weights for this one. So I've started to implement this in the previous video. I changed, in meanwhile, I read a little bit more about this, and I changed the output right now just to replicate the function. I mean, the function is the one that we're trying to rebuild this one. We can, okay, in this one, and we're trying to replicate it in Go. And yeah, I read a little bit about differences between make and just an array. So make creates a slice that creates the underlying array and manages the underlying array by itself. So it's, as I read, it's far more efficient than just working directly with arrays in most cases. So okay, and right now we need to implement several things. The first one is we need to implement the R and T arrays, and then we can compute the X and Y's. So let's go. So for the R, this linspace will return the array of equal distribution of the numbers between the lower end and the high end. So in order to do this, we need to again allocate a slice with, I think it's samples, right? Then I need to fill it. So I think I can try to use range here, bit like this. Okay, so we have I equals to okay, once, because that's the integer, and here we have, so that should be enough. Actually, I'm curious if it will fill the data with zeros, because actually needs, but maybe no. Maybe it's just a convenient way to allocate it in the Python. Okay, so we're done with the R. With the T, we need to Okay, so again, this is the size of the samples, not this one. It's T. And again, for I range T, right? We need to fill it, right? So again, we're starting from here. It's samples multiplied by 4. Then we need to add a fraction. So we're using the, again, I multiplied by, I think it's +1 multiplied by 4. So and I need to rent is it the rent norm float 64 returns a normally distributed float in a range of minus max to plus max with a standard normal distribution means 0 standard deviation 1 from the default source. To produce a different normal distribution, callers can adjust the output using, yeah, I mean, it means that we can change, but I don't need to change the distribution. I need to decrease the value of it. Right? Right. Am I right? Right. Okay, we have T and R. Okay, so in order to use this R, I mean, the problem that we have is the range that goes by samples multiplied by the class number. So, like, for example, if I will have 3 classes, it means that I will have 3 different samples. But the R and T are all allocated with only by the number of samples. So I need a way to use the R and T values, and this we will take the current IX and we minus the class number, which is this one, right? So in that case, we should be able to use the R and the T values because we will kind of offset them. But let's take a look. So we need to, first we need to X and 0. Oh, no. And it will be R multiplied by, I think it's math sin, right? And it will take the T multiplied 2.5, right? Then we have the second value, which is R multiplied by cos. Okay, and then we have the Y value, which is the sample. Oh, it's class number. Okay, class number. Okay, let's check that I'm at least not you know, crashing something. X and Y equals to create, oh, how did I call it? Spiral data. Spiral data samples. How many samples? I think that was 100 samples. 100 samples, three classes, right? X well, it's not crashed. We have some values 0, 0. Then we have some okay, so it looks like I just have the music here. It looks like this is what we need. The main problem right now oh, so the Y is used for the color mapping. Okay, so basically we have in X we actually have the first axis and the second axis, and the numbers are distributed between -1 and 1. I don't see anything that starts with 1, so it kind of looks like what I need. Okay. So what can I do next? The next thing I need to do. Okay, I don't need this. This. Okay, maybe I will read. Right now I need to find a way to plot the points. And I tried to find a couple of the charts. The thing is that I actually need a very simple one. Charts for Go, strip charts, cutters, histogram bar, categories, pairing, boxes and features. I mean, the one thing that I need is just to plot what's called data series, plotting and visualizing data. Example plots. Okay, we have scatter. Okay, maybe I should try to implement this. Right. Generate move. Okay, let's try this one. This is the go get plot. Scatter. Okay, we have data. I mean, maybe I shouldn't. Okay. X and Y make 4 len values. Make 164 len. Okay. Scatter data, line data, random points. What is this? Random points. Okay, so we need to actually convert this into plotter. Okay, PTS, no matter what it is, make plotter XY's number values. Well, okay, and then for range this x equals this. Okay. Okay, so we have the data and we have and define plots. Okay. As file legend. Okay. And then we save into the file. Oh, so I need to set the color. Where is it? As glyph style. What is it? What's color? Oh, image color. Image color. This. Okay. Points example. Okay, plot new. BTS. Mm, Could remove embedded fields. New line data. I'll make a line plotter with points. Add the plotters to the plots. Yeah. B adds S. Okay. Interesting. Make run. Yeah, it's different, but it kinda feels like it doesn't. But I think this is the consistent, right? Yeah. So it looks like one spiral when I should have 3. But the number of uh, 300. Means that I have 300 of values, but it looks like they are not distributed. Oh, but I will just double check and then just to be sure that no, it takes the class number. Well, it takes the class number, right? Yeah, I made a mistake here. Okay, it's a class number. And then class number again. With the range, it takes samples. So right now, develop memory address. No, wait, yes. Yeah. Nice. I mean, the one thing that I can do is to make it colorful. And in order to do this, I mean, I have X and Y. But I think instead of yes, instead of one scatter, I make new scatter equal to number of classes. So what I need to do, I need to take the number of classes. I need to actually run this 3 times, right? And I will need to do the asset. So we have the PTS. Okay. Class less than class. So we have a class, right? Oh. Or class in range classes. Then I'm moving it here. This is divide by len classes. Multiply it. No, wait. Class multiplied by offset plus y, right? Oh no. Class offset plus class offset, right? And then wait, make, okay, I need to random the color. Okay, rand int why? Okay. Okay, we have Then yeah, that's incorrect. Okay, let's just pass the number of classes count for class equals to 0 class count class classes count and classes. Oh, okay, so this is 3, which means that I don't need this. Yes, this is what I need. Okay. Right, so this is finally looks like what I wanted. So I have I need a okay. Okay, so we have 2 types of the green and the blue one. So yeah, it took me for a while to implement this, but yeah, I think this is what we need. The main thing that we actually can plot, oh, we don't need this anymore. We can plot this data, and yeah, in the next video we will go into the implementation of the dense layer class. So we will continue to actually implement our neural network, but we needed this for the debugging purposes, and I think we will need to add probably rendering of the activation function. I don't know, maybe something else. But the crucial here that I found the plotting library that most likely I will go to use for everything. So which one it is? It's a plotter. That should be enough. Okay, thank you for watching, and I see you tomorrow. Bye-bye.